Okay, Hiba. So your first question, out of a pair of complementary angles, one is 2/3 of the other, find the angles. So Hiba, there are two complementary angles. So their sum is going to be what? Okay. Hiba, can you hear me?
Yeah.
See, there are two complementary angles. We don't know what they are going to be. Okay, let's say one is something and one is something else. But we know one fact, and that is they are complementary angles. So if they are complementary angles, what do we know about them? That when you add them, you are gonna get 90. Is that clear? Hiba, I can't hear you.
Can you hear me?
Yeah, now I can hear you. Yeah. Yes, Hiba. So is this clear?
Yes.
All right. So this is one thing that we know about them, that they, when you add them up, they give you 90. Now, one more thing is that the other fact that they are giving you, that one is 2/3 of the other. So if this angle, or let's say, let's call it like this. So there are two angles that when added, they're going to give you 90. Okay. So x plus, let's say one angle, let one of the angles be x. So if one angle is x, what is the other angle going to be? Keeping in mind the fact that their sum is
2x.
90. 2x by 2x.
Sorry, 90 plus 90 minus x.
Very good. Yes, 90 minus x. 90 minus x. So the other angle is going to be 90 minus x. Okay. One angle is x and the other is 90 minus x. Now, the thing about them is that one of them is 2/3 of the other. Okay. One of them is 2/3 of the other. So you can say that x is equal to, or instead, let's do it like this. 90 minus x, you can do it either way. 90 minus x, this one, is equal to what? 2/3 of the other angle. 2/3 of x, right? Till here, is it clear, Hiba? Hiba,
Can you explain it again?
Hiba, was it clear till here?
Can you explain it again?
Till here, was it clear? No?
Yeah.
You want me to restart?
But till here it was clear.
It is clear. Okay. So out of a pair of complementary angles, since they are complementary, we get this step. Fine. The next step is one angle is 2/3 of the other. Okay. When they are saying one is 2/3 of the other, they mean one angle is 2/3 of the other angle. So you can say x is equal to 2/3 of 90 minus x. You can say that, or you can say the other way around also, because you're saying one angle is 2/3 of, Hiba, you understanding? You're
Yeah.
saying that one angle is 2/3 of the other angle. That's how we got this. Okay, because the two angles are x and 90 minus x. The other way that you could have done this is by saying that one angle, which is 90 minus x, is 2/3 of x. You can do it either way. Fine.
Okay.
So which way do you want to choose? It's gonna be the same thing. It's
first
not like
one.
one way is gonna be easier, the other is gonna be difficult. Okay, so you want to choose the first one. So let's do this. X is equal to 2 by 3 multiplied by 90 minus x. So let's first open the bracket on the right hand side. Okay. So it's going to be x is equal to 2 by 3 multiplied by 90. Right? Clear?
Yeah.
2 by 3 multiplied by 90. What's going to be the next thing? What am I going to write after this?
Positive x.
No. How is it positive? How is it going to be positive? See, Hiba, 2 by 3 is being multiplied by 90 and it's being multiplied by negative x. So what do we write next? We have multiplied it with 90 and
So
written it over
2
here.
by 3 multiplied by minus x.
Yeah, so instead you can write minus 2 by 3 multiplied by x, right?
Yeah.
Okay. So now what is 2 by 3 multiplied by 90? This 3 and this 90, you can cancel them. This becomes 30, right? And what is 2 multiplied by 30?
60.
60 minus 2 by 3x. So we're just going to write that as 2 by 3x. Okay?
Okay.
Fine. Till here, clear?
Yes.
Shall we move forward?
Yes.
Okay. So now what do we want to do? We want to bring all of the x's in one place. So we can transpose this to the left hand side. Let's do that. Do you want to do that? Hiba.
Yes. You can do that.
Okay. Fine. So x. Now this negative 2 by 3x, when it goes to the other side, what does it become? Hiba, just a second. Just do it and I'll be back in a minute. Yeah, Hiba. Have you done after this?
No, because I don't know how to do it.
Okay, see. So over here you have, this is negative 2 by 3x, right? 2 by 3x is in the negative, isn't it? So when it goes
Yeah.
to the left hand side, what does it become?
It will be positive.
Positive 2 by 3x. Okay. Then whatever is left on the right hand side, it will be as it is equal to 60. Done?
Yeah.
Clear?
Yeah.
Now, how do you add x and 2 by 3x?
Um. We will multiply two. Sorry, we will multiply 2 and 3.
No, I will do that. Hiba, this is 3 by 3, isn't it?
How?
Because 1 is equal to 3 by 3. Yes or no? When you say
Yes.
3 divided by 3, it's equal to 1. And we just want to be able to basically, fine. So let me go step by step over here. Let me open a new page. So you have x plus 2 by 3x. Fine. Now the thing is, Hiba, you want to add both of these. So how are you going to do that? You will add the coefficients of these x's. Okay. You will add the coefficients. And what is the coefficient of this x?
So it will be 2x.
No. Are we saying are we saying x plus x? Are we looking for x plus x?
No.
No. We are looking for x plus 2/3 of x. Right? Hiba, what is the coefficient of this x? 1, right?
1.
And what is the coefficient of this x?
1.
No. The coefficient is
2
2
by
by 3. Right? It's 2 by 3. Fine. Now, Hiba, what do you do when you're adding two things? When you're adding something and a fraction, or when you're adding two fractions,
So we will find the LCM of 1 and 3.
You can find the LCM of 1 and 3, but you don't have to sit and do this 1 and 3 method, okay? Because
it will be 3.
It will be 3. And you know for a fact that if you want to make this, if you want to make 1 as a fraction whose denominator is 3, then it will be what? 3 by 3, right?
Yeah.
Let's say if you had something, if you had 1 plus 49 by 50, what will you do? Immediately you will say this 1 is nothing but 50 by 50. And why did we choose 50? Why not something else? Because the denominator we need is 50. Right?
Yeah.
So 1 can be written as whatever you want. In fact, any number can be written as whatever you want. Right? So if you want, you can write it as 2 by 2. If you want, you can write it as 3 by 3, 4 by 4, 5 by 5, 10 by 10, and so on. Okay. So now, can we add this 3 by 3 and the other fraction? Can we add these two now?
Yeah, but why do we want 3 by 3?
Okay, Hiba, if there is anything else in the denominator, how are you going to add it? How will you add it? Like, let's say if it's 2 by 2 and this fraction is 2 by 3, how will you add them? You will again sit and find the LCM, right? Then you will find the LCM, it will turn out, oh, okay, the LCM of 3 and 2 is 6. Then you will say 2 3s are 6, so 2 3s are 6 plus 3 2s are 2 2s are 4. So why do you want to complicate things for yourself? Are you understanding what I'm saying?
Yeah.
Why we chose 3 by 3 was because 1 if you just want to do 1 plus, wait, 1 plus 2 by 3, you are going to have to convert this into a fraction anyway. Getting it?
Yeah.
So, okay, if you don't want to convert this into 3 by 3 in the first step itself, then it's fine, no problem. We can do that later on. So, fine, if you don't want to do this way, we can just write it as 1 plus 2 by 3. Fine. Now you can write this as, just at least you can do this, right? You can put the denominator as 1. And now you will say, okay, so this, the LCM of 1 and 3 is 3. So now you will multiply it. So 1 3s are 3. So this 1 multiplied with this 3 gives you 3 plus 3 ones are 3. So this 2 multiplied with this 1 will give you 2. So you have 5 by 3.
2.
Okay, if you would have done it the other way, you could have gotten it easier and more easily. How? You could have just said 3 by 3 plus 2 by 3 is simply 5 by 3. I can just easily see that 3 plus 2 is 5. Done. Are you understanding why I chose that method?
Yeah.
Okay. Fine. So now can you tell me what's going to be this left hand side of the equation? Yes, Iba? Hey, Ba.
I forgot.
What did you forget?
Can you explain it again?
Okay.
The left hand side.
Okay. Hiba, I just want you to give it a try yourself. Okay? Give it a try. Just think, what are we going to do now? Tell me. Think out loud, basically. Yeah?
We will
Think.
we only need one variable.
It's not that we only need one variable. We are just trying to add them both together. Right? Yeah? Hiba? Does that make sense?
So like, yeah, so it will be 1 plus 2 by 3 and we
Okay.
yeah, so it will be 3 by 3.
Very good. So this one will basically be 3 by 3. And then we have this.
But how will it be 3 by 3?
Okay. It won't be 3 by 3. Forget it. Okay. Forget it. Just tell me, how do you want to solve? Like, you know how to solve fractions, right? Tell me, how do you solve this in your own method? Don't follow my method. How will you solve this?
1 by 1 plus 2 by 3.
Yes.
Then it will
See,
be 3
Hiba,
by 3.
how will this be 3 by 3 now?
No,
Now,
like
why
the
is it
whole
3 by
answer.
3? The whole answer will be 3 by 3. Is that how we add?
No.
Then, what is the condition for adding two fractions?
We have to first find the LCM and then we have to multiply with a number that gives the same denominator.
Yes, yes, exactly. So let's do that.
So 1 by 1 multiplied by 3 on both sides.
Then
It will be 3 by 3.
now it's 3 by 3.
Yeah.
So are you seeing, are you getting the answer to your own question now?
Yeah.
You got your answer?
Yeah.
That why is this one 3 by 3? See, we can just write equivalent fractions according to our own wish. Okay, let's say for example, if I had 7 by 6, no wait, 7 by 9, okay, plus 2 by 3. Okay, then I will say, wait, I can just write 2 by 3 as, I can write it as, I can write an equivalent fraction of it, right? It's the same thing. Its value is not changing. So if I write it as 6 by 9, then that's also the same thing. So instead of 2 by 3, I can replace it with 6 by 9 because it's the same thing. So that is what we can do. Like in, in math, we can just write one thing in the form of another thing. Okay, we can just, like as per our convenience, we can change, we not exactly change, we can replace numbers with their equivalent numbers. So now is it clear till here?
Yeah.
Okay, multiplied by x. Now what happens next?
We will add them all.
Yeah, then
So it will be 5 by 3.
5 by 3 x. Okay. Hiba, can we just take a quick 5-minute break? So 1 sec. 5 by 3 x is equal to, what did we have here? 60, right? 5 by 3 x is equal to 60. Can you please solve this? I'll be back in like 5 minutes, okay?
Okay.
Solve this. I'm back. Yes, Hiba. You back?
Yeah.
Okay. So what did x turn out to be?
36.
36. Very good. So x is equal to 36. So what is 36? What is 36? What is x? What is
36.
x? No, no, no. What did we say
What?
x was in the beginning? X is an angle, right?
Yeah. 2 by 3.
No. X was one of the angles. So there was two angles. One angle was x. The other angle was 90 minus x. So x, which turned out to be 36 degrees. Okay. And now
So
the
it
other
will be
angle, which
90
is,
minus 36.
yes. So what is the other angle?
90 minus 36.
And that is,
Um. 54.
very good. So it is 54 degrees. So now, is it clear how to find these two things?
Yeah.
Okay. All right. So question number 2, part A and B, you have written player 4, player 4. Very good. Next 3, you've written as false. Okay. Two right angles are complementary to each other. False. Okay. What would the right sentence be in this case? What would the corrected sentence be?
Can you repeat the question again?
Question number 3 of your assignment. Two right angles are complementary to each other. You have written false, which is true, by the
Yeah.
way. Matlab, it is false. So, what would the right sentence be? What would the correct statement be? Two right angles are complementary to each other. That's false. Then, what is the correct statement?
Two two
Right angles?
right angles are complementary to each other.
No, that is false, right? That is false. Two right angles are
Oh,
complementary
sorry.
to each other. This statement is false. So,
With
how
two
would you make
acute
this
angle.
statement true? No. See, two right angles. What I'm trying to mean over here is two right angles are, okay. You know what? Let's skip this because it's coming in the following question. So let's skip this. So question number 4, you have written as false. Let's see. One obtuse angle, one acute angle can make a pair of complementary angles. Very good. It's false. Then the next one, two supplementary angles are always obtuse angles. You have written that as false. Okay. Two supplementary angles are always obtuse angles. It's gonna be wrong because if one is obtuse, then the other angle has to be acute, right?
Yeah.
Then question number 6. So this is what I was talking about. Question number 6 is true. Two right angles are always supplementary to each other. So what I was saying was in question number 3, it is written as two right angles are complementary to each other. So the correct statement will be, no, they're not complementary, they are supplementary. Two right angles are supplementary to each other.
Yeah.
Okay. Then question number 7. One obtuse angle and one acute angle can make a pair of supplementary angles. You have written true. And 8th one, both angles of a pair of supplementary angles can never be acute angles. You have written that as false. Both angles can, it's true actually, Hiba. What are they saying? They're saying that if there's a pair of supplementary angles, okay, supplementary angles, their sum is 180. Let's say this is one angle and this is one angle. They, both of them cannot be acute. That means it cannot be that both of them are acute, which is true, right? Only one
Yeah.
of them can be acute. Both cannot be acute.
But
So
like
it's true.
I searched it on Google and it said that it can not always be obtuse.
Yeah, see,
Sorry,
we are
it,
not
it
saying
can always be acute angle.
what? What did you say? It can?
It can never
It
always be
can.
acute angle.
Okay, you are saying that it can be acute.
Yeah.
Hiba, just send me what link you saw, okay? But just think about this, that if you have two acute angles, okay, fine, let me give you two acute angles, 85 degrees and another acute angle 89 degrees. Are they both acute angles? Yes, because they are less than 90, right? Any angle less than 90 is acute angle. So they are both acute angles. Add them and tell me whether they are supplementary.
So both angles has to be acute angle.
That's what we are saying. It cannot be that both are acute, because in this case, this is also an acute angle and this is also an acute angle. When you add them, what do you get?
It
You get 174
174.
degrees. Is this equal to 180?
No.
No, right? And just think about it. It's kind of self-evident that if you have two angles, both of them are acute. Let's say this is one acute angle. Okay. Acute basically means less than 90. So, okay, forget about acute angles. Let's talk about right angles, right? When you have
And it
two right angles, they are going
can
to
it
add up. Yeah.
can it be just 90, like
See, if both of them are 90, then it is going to be, they are going to add up to be supplementary, right?
180?
Yes,
Yeah.
supplementary 180. If one of the angles, if you take two angles, one angle is 90 and one angle is 89, are they going to be supplementary? This is acute, by the
No.
way. This is acute and this is a right angle.
Right.
Are they going to be supplementary? No. So if this angle is also acute, the other angle is also acute, let's say it is, for example, 80 degrees. Is it going to be supplementary? Are they going to be supplementary angles?
No.
No. So you see how that's happening, because if one angle is acute, then the other has to be obtuse. Okay. Like if you see
Okay.
this one is acute, right? This angle is acute. So automatically, what does the other angle become? It is automatically becoming an obtuse angle. Are you seeing how
Obtuse
that's
angle.
happening?
Yeah.
So listen to, like, read the question carefully. It says both angles can never be acute angles. That is true. One of the angles can be acute, but both at the same time, they cannot be acute. Are you getting it? That both at the same time cannot be acute. That is what the question is meaning. Got it, Hiba?
Yes.
So the answer will be true. Now,
And for the ninth question, the answer is also true.
you've not written it in your notebook, I think. An angle is more than 45. Its complementary angle must be less than 45. Yes. And
I forgot to
it's the
mention.
same logic that we have applied in the eighth question, by the way, right? That if an angle,
Yeah.
when we're talking about supplementary angles, if an angle is more than 90, which is obtuse, then the other angle automatically it has to be less than 90, which is acute, right?
Yeah.
Hmm.
It will be
Okay,
true.
it will be true. Fine. So that's it for the assignment. Now let's talk about a new topic. Wait, did you do the assignment on adjacent angles? I asked you to do all of these, try these and everything, right? Did you do those?
No, you didn't tell me.
I didn't tell you. Hmm. You know what? Okay, fine. I'll send you the assignment. Actually, I remember telling you to solve the try these, but I don't know. Maybe I didn't. Anyway, so Hiba, please solve the try these, okay? The
Yeah, you
try
told
these,
me.
yeah, the try these
But
till page number.
at that time, I didn't know what adjacent
Okay,
angles
fine.
were, so I didn't do.
All right. So you do the try these of page number 97, page number 98. That's your homework.
Okay.
Fine. Now let's talk about something which is basically, it means a linear pair. Okay. What does a linear pair mean? Linear pair is a pair of adjacent angles first of all, they have to be adjacent angles. Okay, adjacent angles which make 180 degrees, basically adjacent angles that are supplementary. Okay, adjacent angles that are supplementary. You know what's linear? What does linear mean? Can you see from which word it is possibly made, the word linear?
Line.
Linear. Yes, very good. Line. And if you take a line, and if you see this angle, what is this angle?
180 degree.
180 degrees.
Straight angle.
So, yeah. So a straight angle, exactly. So a linear pair, it means those two angles which basically they lie on a line. Okay, those two angles which lie on a line, that's why it's called linear pair. Fine.
Yeah.
Okay. For example, if you just take a look at uh, some daily life examples of linear pair on page number 99. Okay, are you seeing the two angles on the chopping board?
Yeah.
Yeah. So they are both making a linear pair, right? The angle on the left and the angle on the right. They are making a linear pair. Then the pen stand. They are making those two angles are making a linear pair. Okay.
Okay.
Yeah. Let's discuss this. Think, discuss, and write. Can two acute angles form a linear pair? Same page, page 99. Think, discuss, and write. Can two acute angles form a linear pair? Hiba?
What is? I didn't understand what is a linear pair.
Meaning of
Linear pair.
linear pair is a pair of adjacent angles that are supplementary. Okay. For example, let me give you, I just gave you an example over here. Let me give you another example. And we just saw some daily life, some real life examples on the same page, page 99. Okay, you can see those two things, right? Those two angles are linear pair. For example, if you take this is a line. Okay.
Yes.
And you have what?
Take two acute angles can form a linear pair.
What did you say, Hiba? Your voice is not clear.
Two acute angles can form a linear pair.
Is that true or false?
It is true. Like 40
It's true?
plus
40
yeah.
plus?
40 plus 140.
40 plus 140.
Yeah.
140 is an acute angle. 140 is an acute angle, Hiba. What?
No.
No. Then
It's
what is the
the
question asking?
two acute angles
Two
can't
acute
form a
angles. See,
linear
two acute
pair.
angles can never be supplementary, right? Can they ever be supplementary? Can their sum ever be 180 degrees if both of them are less than 90? Can their sum ever be 180 degrees? No. So can two acute angles form a linear pair? No. Is that fine, Hiba?
Yes.
Can you answer the next part, the next question? Can two obtuse angles form a linear pair?
Yes.
Just a minute. Huh? Yes, Hiba.
Yes, they can form a linear pair.
Can two obtuse angles form a linear pair? We just now saw this, right? If both of the angles are greater than 90, see, if both of them are obtuse angles, let me just draw two angles that are obtuse, okay? This
Obtuse
and this.
angle
Okay,
is
this is
like
an obtuse.
it is less than 90 degree. No, sorry, it is more
Obtuse
than
angle
90
is greater
degree.
than 90, Vatsa. What is obtuse angle?
It is greater than 90 degree and less than 180 degree.
Yes, exactly. Just a second, Hiba. So, yes, an obtuse angle is greater than 90 and less than 180. So, if you have two obtuse angles, let's say this is one, and the other one is, let's say, this is also an obtuse angle, right? So, are these two making a linear pair? No, they're not making a linear pair. Yes, they are adjacent angles, but they're not making a linear pair because they are not lying on a line. They're not making a line, right? This end and this end are not making a line, a straight line. Are you getting it?
Yes.
So what will be the answer for the second one? Can two obtuse angles
False.
form a linear pair? Yes, the answer will be no. Can two right angles form a linear pair?
Yes.
Yes. Okay. Uh, let's quickly do the try these. Check which of the following pairs of angles form a linear pair. Part 1, 140 and 40.
Yes.
Yes, because they when
Their
you
sum
add them,
add up to 180.
yeah. Then the next one, 60 and 60.
No, they can.
No, because it will be 120. Then 90 and 80.
No, it can't.
No, some will be 170. 115 and 65.
No.
115 and 65. Hiba, when you add them, what does it give you? It gives 180, right? Yeah.
Yeah.
Okay. Now comes this thing which is, I personally find it very interesting. It's called vertically opposite angles. Okay. And here's why I find it very interesting. It's very easy. So when you have anything that looks like an X, okay, and you have these, how many angles can you see here?
Two.
You can see two angles. I can see four.
Oh, yeah, four.
One,
Yeah, one,
okay,
two, and
angle two, angle three, and angle four. Now, the special thing about vertically opposite angles is that the angles that are opposite to each other, which in this case means this angle and this angle, are going to be equal. Okay. So what do we know? What did we just see? Vertically opposite angles are equal. Okay,
Okay.
vertically opposite angles are equal. An example of this, you can see it when you take a pair of scissors. Okay, so you can like expand the scissors, and you can then
Yeah.
contract the scissors. So you see, whenever you expand them, so there's this, let's say this is the thing. Um, okay, and then this is your, oops, one sec. Okay, so Hiba, the thing is, the more you open your scissors, the more you open it, right? The more this angle becomes, like the more you open it like this, the more this will also increase, right? Have you noticed it? Do you have a scissors in front of you anywhere? Just take a look at it and just do this right now. Try observing these two angles, this angle
Okay.
and this angle. Yeah, quickly
Yeah,
do
I
it.
tried it before.
Yeah. So what is happening when you are you trying it right now, or are you saying that you've already done it before?
Yeah, I've already noticed it before. Like done it before and I've
Yeah,
already.
good. Yeah. So as you increase this angle, the angle between the handles will also increase. Okay.
Yeah.
So that's because they are both equal. They are, in short, we write it as VOA, vertically opposite angles. Okay. So vertically opposite angles are equal. Um, okay. Let's do the try these. Okay. Try these, page number 101.
Okay.
Page number 101. In the
Yes.
given figure, if angle 1 is 30 degrees, find angle 2 and angle 3. Hiba,
Why
can you
is
see
there
it?
no angle for?
Because they're not going to ask you about angle 4. I mean, it's there. They just haven't marked it because it's of no use in this question, right? It's of no use in the
Yes.
question. That's why they haven't marked it. Otherwise, it's there.
So it will be 20.
They're asking find angle 2 and angle 3. So let's do one thing. Forget about angle 2. First, find angle 3.
It will be
Yes,
30.
Hiba? Very good. So because angle 1 is equal to 30 degrees, angle 3 will also be equal to 30 degrees. Okay. Now they are saying find angle 2. So for this, do one thing. Ignore angle 3. Just look at angle 1 and 2. What do you think angle 2 will be?
2 multiplied by 30.
No. Why?
40.
It's just the name. It's just the name of the angle, angle 2. It's just the name. It doesn't mean it is twice of it. It's just the
40.
name of the angle. Huh?
40.
Why 40? What makes you think so?
Because it looks bigger than angle 1 and 3.
Yeah, it looks bigger. So why only 40? Why not 50 or 60 or 70 or 80 or 90 or anything else? They're also bigger. Okay, Hiba, look here. Take a look at this. Okay, and this. Do these two look like a linear pair to you? Yes. They are falling on a straight line, these two angles.
Yeah. No.
Yeah. So now, can you tell me what the blue angle will be? This one?
Can you say it again?
Okay. Uh, can you just notice, just observe how these two angles, this one and this one, they are both falling on a straight line. They are making a linear pair. These two angles, angle 1 and angle 2, are making a linear pair. So that is a hint. Now tell me, what do you think that this angle will be? If this is 30, then what will this be? If they are making a linear pair.
60.
If this is 60 and this is 30, will they add up to be, will they make a linear pair?
No.
Does 30 and 60 make a linear pair?
We have to make it like 180.
Yeah, the sum has to be 180. So what will the second one be? This angle has to be, what will you do? It's going to be 180 minus 30, right?
150.
Very good. It's 150. How did we find that? Because linear pair. So that means the sum will be 180. When you subtract 30 from it, you get 150. Okay. And so obviously the other angle, this angle 4, is also going to be 150. Even though they haven't mentioned it, we just found it out. Okay. Okay. Hiba, now your homework is, wait, we are having our class day after tomorrow, right? And tomorrow you have a holiday, so you have one whole day to complete your homework. By the way, did you find out when is your exam going to be?
No.
Okay. And try out exercise 5.1. Okay.
Okay.